we are going to take a look at 4 basic polar graphs. It's nice to start with those, get kind of comfortable in how to graph in polar, and then we can go to the more complex types of graphs. So the first one we're going to start with is when we have just r in the equation, and specifically we have r is equal to some constant, some real number. So in this one we're using r is equal to 3. Now a great thing to do when you don't know what a graph looks like, whether that be in polar or rectangular, is to create a table. So in this situation, what this is saying is that whatever you pick for theta, so say I pick pi over 4, because theta is not in the equation, it doesn't affect the r, so r is going to be 3. Or if I pick theta as pi over 2, r is going to be 3. Or if I pick 5 pi over 6, r is going to be 3. Right? I could pick 3 pi over 2, and r is still going to be 3. So here in this situation, let's plot these points, right? I have pi over 4, which is right in the middle of quadrant 1, 3. I have pi over 2, 90 degrees, 3. 5 pi over 6, 3, and let's do 3 pi over 2, and it's always 3. So if you can imagine that you look at the first counterclockwise revolution, you're looking at the angles from 0 to 2 pi, it's always going to be 3. And remember that when you're picking an angle, right, the angles are encompassing the full circle. So because it's always going to be 3, it's going to create a circle of radius 3, where the center of the circle is the pole. The pole is the origin. So what happens here is we can connect all these points into a nice of circle as we can get it. And here it is. So now that you know what this is always going to look like, right, you don't need to pick specific points. You can go right into drawing the circle. So let's generalize this. So when we have r is equal to, say, k, where k is any real number, so anything from negative infinity to infinity, it's going to be a circle with the center at 0, 0, where the radius is the absolute value of k. Because even if r is negative, remember, the r being negative just means that you go directly across. You go 180 from the angle. But it would still be a positive radius for the circle when you graph it. So if this right here, this graph would be the same thing as r is equal to negative 3. They would look exactly the same. All right, so this would be case 1. Let's look at case 2. So we have that theta equals 4 pi over 3. So now the tables have turned. Now we're given theta, and r can be anything. So let's draw a little table to help us out. So say, for example, I pick r is 2. Well, the angle is going to be 4 pi over 3. I pick r is 4. The angle is 4 pi over 3. I can also pick 0. The angle is still going to be 4 pi over 3. What if I pick like negative 3? Oh, well, the angle is still 4 pi over 3. So let's plot those to kind of help us visualize what's happening, right? So 2 comma 4 pi over 3, 4 pi over 3 is in quadrant 3, and I'm going to a positive 2 radius. Then if I go to 4 comma 4 pi over 3, that would put me still in quadrant 3, but a little bit further down. 0, anytime the radius is 0, that means that you're at the origin, no matter what the angle is. And then if I have a negative radius, that means I need to go backwards. I need to back up from 4 pi over 3. So 1, 2, 3. So if the r can be any real number, right, it can even be a decimal. It could be 1.5, 2.7. When you take all of those radiuses and the negative versions of them, what ends up happening is you get a straight line going through the origin at the angle that you are looking at, and also at the angle straight across from it. So here it is. Let's generalize that. So theta is equal to k, where again, k is any real number, negative infinity to infinity. So this is going to be a line going through the origin. So it's going to be a line through the pole, which we know in Cartesian or rectangular is 0, 0. Okay, so it's a line going through the pole at your angle theta. Okay, let's take a look at the last two cases. So now in these two, I do have a theta and I do have an r. And there's a little bit of a trick to do these two that actually makes it very easy to graph, and that is to use our conversion formulas. So you have 4 conversion formulas from rectangular to polar, and the two we're going to use is actually I write it here on the sides, that x is equal to r cosine theta and y is equal to r sine theta. So if you take a look at case 3, well, actually, I have r cosine theta. So to graph this, the easiest thing to do is to change this to a rectangular equation. And what I do is I get that x is equal to -2. Now from algebra, we know that this is a vertical line going through x is equal to -2. So x is still right on the horizontal line, so x is -2 is right here. But the key is you got to make a vertical line, and it's going to look a little strange because you're making a vertical line on a polar graph, but it's okay. So what I'm going to do first is I'm going to do it dashed to help me kind of make it a little bit more straight, but it needs to be solid. It's just going to create a nice little, and here's my graph. So very similarly, right, we have 3 is equal to r sine theta, but r sine theta is y. So I get y is equal to 3, and from algebra, we know that this is a horizontal line. And so I go to y is equal to 3 here, up on the positive y-axis. Again, I'm just going to make it dashed first to create a nice little, and here we go. And here it is. Not so straight, but you get that it's supposed to be a straight line. So let's generalize this, right? So anytime you have r cosine theta is equal to some k, where again k is any real number, positive or negative, then what that's going to be is it's going to be a vertical line through k. And anytime you have r sine theta is equal to k, again, let's write k can be any real number. It's important. So it could be like 2.5 or 1.8. It doesn't have to be a whole number. This is going to be a horizontal line. And there we have it. 4 basic polar graphs. So it's going to be very nice, right? We're going to be able to now kind of build on that and kind of graph more complex graphs. So here they are, all 4 of them. 1 circle and 3 lines.